Assalamu alaikum. The topic that we are going to cover in this lecture is fixed point iteration method. Before we go deeper into the discussion about fixed point iteration method, let us have a look at the topics that we have learned so far. In our previous class, we have learned about two numerical methods for solving equations. Those were basically bracketed methods. Why? The topics that we learned in our previous classes were bisection method and false position method. If you remember, in both the methods, we started our proceedings by approximating 2 points, and then after each iteration, we would get another point, but the point would fall between these bracketed two assumptions that we started our calculation with. So that is why these two methods are called bracketed methods. Now we want to move our discussion towards open methods, or we can say it in other words, in this type of numerical methods, we would not start our approximation with 2 points. Rather, we will start our approximation with 1 point, and then we will run a formula, or that will give us another iteration, and then we will get another point or another results. And in this way, after multiple iteration, we will reach to a point when we can say that we have found the original root. So the first numerical methods that falls into the category of open methods, we will discuss about fixed point iteration method. Let us now discuss how the fixed point iteration method works. In our previous numerical methods, we were given some functions, and we got the function in this form. And if we look at the graph, we were trying to solve the points, or we were trying to find the points where this function intersected the x-axis. If this is a given fx, so the roots of these functions are these 2 points, or these 3 points, we can say. The main idea of the numerical methods that we have learned is to find the roots of the given function. Now look here, if we have a function that can be written in this form, fx equals to 0, we can also write it in this way. By adding x in the both sides, we can write it in this way also. That shouldn't be a problem. So that makes the mathematical statement x plus fx, and at the right hand side we have x. Now look here, at the left hand side, we still have a function of x that we can denote as another way, g of x. And at the right hand side, we have another function of x, which is x, or if we want to draw it in separate form, this is basically y equals to x. And in this part, we have this g of x is equals to x plus f of x. So now we started from fx equals to 0, and now we are here. We are saying that g of x is equals to x. That means these two functions are necessarily are equal. That means if we can draw it in graph, let's say this is g of x, and obviously this is yx, or the function at the right hand side. And in our mathematical statement, we have written that g of x is equals to x. That means the point these two graphs intersect is one of the roots of f of x. So the main idea of fixed point iteration is that the initial step is that we have to rewrite our given f of x in this form. That will mean the intersecting point between these two functions is basically a root of this f of x. Now we have set the tone for our numerical method called fixed point iteration method. So now our goal is to find the point where these two functions are basically intersecting, and finding that point will give us the root of the f of x that we started our calculation with. So far what we have seen, let us summarize that in our initial classes or in our previous lectures, we have seen numerical methods that helped us solve equation if given in this format, right? F of x equals to 0, and from here we used different methods to solve the roots of this equation. Now we have seen that this function can also be rewritten in this format. So that will mean if we can solve the intersecting point of these two functions, g of x and f y equals to x, that is also a root of f of x. So now, using the fixed point iteration method, our goal is to find this intersecting point of g of x and x. Now we will look how we can get to this fixed point that we are looking to find. Okay, the algorithm is pretty simple. We have to, step one here is to, we have to guess one point. So our goal is to get to this point, but we have to start our proceedings with one guess. And that is, we have to guess one point, let's say that is x0. After one iteration, we will get the next value x1. The formula that we will follow to get the next x is this. Or in other words, we can generalize this format in this way. Xn plus 1 is equals to g of xn. And after each iteration, we can find the value of error percentage, that is, we know from the numerical methods that we have learned before is this. So we will start with one guess, that is x naught, and we put the value of x naught into this function of g, that will return a value x1, and then we can change, uh, we can plug x1 into the function. Then we can plug the value of x1 into the g function again, and that will give us again x2. So we can write it in this way. We have to start with xn, and it will go inside g, and that will give us xn plus 1. Then we will replace x of n by this, and then again run it in this loop. So at each iteration, we will see whether we are converging or diverging. How we can calculate whether we are converging or diverging? We can look at the amount of error. If the amount of error is getting lower and lower after each iteration, that means we are converging. If the amount of error is getting bigger and bigger after each iteration, that means we are diverging. If we are diverging, that means our initial guess was not a correct one. So that means we have to start with some other point. So the main idea here is that we will rewrite our f of x in a different form, and then we will start our proceeding, mathematical proceeding, to reach to this point where the two functions intersect, and that will necessarily give us roots of f of x. And how we can get to this point? We have to start with guessing one point x0 and putting it into this function and run the iteration over and over again till we reach to two consecutive iterations where the amount of error is very much lower. In this way, we can reach to this point. Let us now look at one mathematical example that will be that will make the proceedings more clearer to us. Let's say we have a function f of x that is cos x minus x. If we are asked to solve this, then we have to think f of x is equals to 0. What we have learned in a few minutes earlier, that to solve this equation using fixed point iteration, we have to rewrite our f of x in a different way. We can rewrite it in a different way by adding x to the both of the sides of this equation. That will make the left hand side cos x and the right hand side will make x. See, now we have reached to a point we can write it in this way: g of x and x. So we have cleared our step 1, then we have to move to the step 2. So that is, we have to start with a guess, and let us guess x0 to be 0.75. And make sure while calculating you are keeping your calculator in radian mode, because we will put this value into cos x. Okay. If x0 is 0.75, that means x1 will be g of x0, which is cos 0.75. If you have a calculator with you, you can easily find that 0.75 is 0.73169. So we have found first two values of x. So what will be the x2? X2 will be g of x1, that is cos x1, that is 0.73169. So that gives us 0.744. In this way, we can run our iteration over again and again. We get again 0.7357. So in this way, we can run our iteration over again and again, and at each iteration, we can find the value of error or error percentage, and we can check whether the error percentage is decreasing after each iteration or not. If it is decreasing, that means we are converging towards that fixed point where I think you can imagine very clearly that cos x graph would look like this and y equals to x will look like this. So our goal is to reach to this point. So in this way, after running a few iterations, we will definitely reach to this point. So that is one mathematical example how our fixed point iteration is meant to work. If we look deeper into the mathematical aspect, what we have actually done by doing these iterations, let us look here. We started with one point in x-axis where we took one guess of x0. Okay, so let's see, this is our x0. And how did we get the x1? We took we put this value into the function, and the output of the function was our x1. And how we got to that point? Let's see here. We got to that point by, if we put x0 into the uh, function, so this is the point, that is g of x0. G of x0 is our x1. How we can get to that x1? So this is the value in y-axis, that g of x0, as the function on the right hand side is y is equals to x. That means whatever the value of y we got for g of x0 is our x1. Okay, so this is how we got the next point. And from x1, we calculated the g of x1. So what is our g of x1 here? We move upwards. This is our g of x1. And the value of g of x1 is at y-axis is this: since y is equals to x, so this is the value for x3. So in this way, see, we started from this point, we reach here, and then we went upwards, and then we will basically spiraling towards this point or destination. Okay, if you plot or look at all the points that you have found in the previous maths iteration, you will find that in this way we spiraled into the fixed point that we were looking to solve. So the main idea of fixed point iteration is that initially we have to rewrite our given f of x in a different way. Then we have to start our calculation with our initial guess and then put it into this algorithm that x of n plus 1 is g of, and then keep iterating, and finally we will get to this fixed point that we are looking at. So that was the main idea or basic idea of fixed point iteration. We will see an example. Next up, we will see one example where we can, next up we will see an example where we can see there is another method of determining whether the function or the calculation we are doing is converging or not. In our discussion so far, we have seen that the one way to determine whether the function is or the whether the method that we are approaching to solve our equation is converging or not is by looking at the percentage of error. There is another method of looking at it. We will see it while solving the example that we are going to do next. So now we have a problem here that says find the approximate root of given f of x and with the initial guess of x0 1.5. Okay. If we have to solve it using fixed point iteration method, we have to rewrite our f of x in a different way as we have seen so far. We have to convert our f of x into this format. And now here is the catch. Let us now begin the proceeding. The given f of x here is x cube minus 2x minus 1, and that is we can assume to be 0. From here we have to write or bring it into this format so that we get a function of x at one end and we get x at another end. Okay. Now if we look at this given function, there are multiple ways we can come to this point from this given function. Let us see how. Option 1 can be this, that we can rewrite this function in this way. So in this way we get one function at the left hand side and x at the another side. Another option can be so this is another option, another way we can write or convert our given f of x into this g of x equals to x format. We can convert it into another way that can be this way. Now we have three options of converting our f of x into this format of g of x equals to x. So the question now arises which one or which g of x we are going to pick and proceed with our calculation. To solve this type of issues, we have another method or another way of looking at it. That is, if at any point we reach to this type of situation where converting f of x equals to 0 to g of x equals to x gives us multiple options, in that case we have to pick one g of x, and the method that we need to use in order to pick the correct g of x is that we have to uh, we have to pass all the g of x's through this filter. To simplify the thing is that we have three g of x at our hand. We have to namely their g1x, g2x and g3x, and we need to take derivative of all the given g of x's. So we have to do this for all the g of x's and then check the value with the initial value of the x that in our question it was asked us to consider. So we have to then check for this whether the modulus of this value is less than 1 or not. We have to do the same for the second g of x that we have at our hand, and then we have to run the same thing for the third g of x that we have in our hand and check whether the value is less than 1 or not. If it becomes true for all the cases, then we are good to pick any of the g of x that we have at our hand. If only one of the g of x pass through this filtration, then the one that went through is eligible to be our the g of x. So now let us begin our calculation. If we rewrite the functions here, so we have to check what happens if we put the value of x is 1.5. So we can see that this will go beyond value 1. So this is not our desired g of x. Let us check it with the second gx we found. That was, if we differentiate this function, then we get, and if we put the value of x as 1.5 here, so it's obvious that the value here goes beyond 1. So this is also not our desired g of x. Let's check it for the third g of x we had at our hand. That was cubic root of 2x plus 1. The differentiation of this function will give us, or we can say or rewrite it in this way. If we put the value of x as 1.5 into this function, we will see that the modulus, by taking the modulus, it falls or it becomes less than 1. So this is the g of x that we are going to consider for our fixed point iteration case. So now we are good to go to solve this problem. For our case, the g of x here is cubic root of 2x plus 1, and here we have to apply this algorithm. The initial value of x0 is given as 1.5. So by using our analytical methods or our calculators, we can calculate x1, x2, and so on, and see where we can reach finally and get the exact or approximate root of the given f of x. So that is another method of knowing whether the function is converging or diverging from from this formula of g prime x modulus is less than 1 or not. If it is less than 1, that means this g of x is good for our calculation, or by picking this g of x will make the calculation converging towards the fixed point that we are looking to find. And if this is not this way, if this is greater than 1, that means if we start our calculation with this g of x, we will not converge towards the fixed point that we are intended to find. Rather, we will get diverged from the fixed point. So it is another way of knowing whether we are in the right track or not. So that was the basic discussion of fixed point iteration. Thank you for your attention.